we're going to start going through PQ question 3. This is PQ question 3 of power series. We have x cubed minus x minus 1. You need to first express this in partial fraction. Okay, so I hope your partial fractions are sound. If it's not, please go back and revise your partial fraction. So observe that we have this function. This is x cubed minus x minus 1 over x squared minus 1 multiplied by x plus 1. Right? So what's next? Okay, you observe. So remember I told you before that you always have to appreciate the degree of the numerator and the denominator. And we say, oh, this actually is you can see the degree of the are the same. Okay, the top is degree 3, the bottom is degree 3. So this is an improper fraction. Okay, so because this is improper fraction, what do we need to do? We need to long divide. Okay, so we need to do long division. So before we do partial fraction, always make sure that it is a proper fraction. In this case, this is an improper fraction. Okay, so let's expand the denominator. We have x cubed plus x squared minus x minus 1. Okay, so this is the denominator, and the top we have x cubed minus x minus 1. Okay, now taking the numerator and we divide it by the denominator. Okay, what we get is our first case. So we just compare the powers for this x cubed. This is x cubed. We have power 1. We multiply by 1 minus x cubed plus x squared minus x minus 1. Okay, after that you have negative x squared minus x. So minus x minus, so it's minus x plus x. So you just 0 minus 1 minus, so minus 1 plus 1. So you're just left with negative x squared. That's all. And also this is the remainder. This is the quotient. This is the divisor. And this is what we call the dividend. Alright. Then after that we can form up our partial fraction. So eventually our answer in partial fraction form, this is just equals to 1 numerator, remainder, so numerator write it on the top, minus x squared over, this is our, remember that this is our denominator, this is the divisor, right? But we try, instead of writing in this form, let's try write it back in this form. So why do we write it in this form? So that we can do our partial fraction later. It will be convenient to use our partial fraction later. Okay, so it's 1. Okay, and this is the expressing our function as in terms of partial fraction. Okay, what next? Okay, so if you go back, okay, what next? The next part is hence to find the series expansion in ascending powers of x. Okay, so we need to find a series expansion. How to find series expansion? Okay, so we take a look and see. Oh, okay, first we are not done with the partial fraction yet. Okay, so it's 1 minus x squared over x minus 1 x plus 1 bracket square. Okay, we haven't finished it. Okay, so we just take this portion and we try to do partial fraction. Okay, you observe the x squared minus 1 is the same. Originally, just now we have x squared minus 1, so this is the same as x minus 1 x plus 1. Okay, so x plus 1 you have x plus 1 square. That's why you have x plus 1 square. Okay, and using carve-out rule, what you can do is you can use carve-out rule to find. Okay, first let's write it in this form. This is equals to a over x minus 1 plus b over x plus 1 plus c over x plus 1 square. Then we can use carve-out rule. Okay, use carve-out rule to find our a. Okay, how to find the a? So next we are going. Okay, so we basically, if you want to use carve-out rule to find a, we sub to find a. We sub x equals to 1. We cover x minus 1. Alright, so for here, just think, if we cover x equals to, we sub x equals to 1, this will give us 1 square. We cover x minus 1, then at the bottom, sub x equals to 1 plus 1 square. So this is 1 over 2 square, which is 1 over 4. So a equals to 1 over 4. How about b? Okay, so we are going to find b. So to find b, we can't use carve-out rule. We can use carve-out to find c. Alright, so remember that we can only use carve-out rule for distinct linear factor as well as a repeated linear factor of the higher order. Okay, then this is x plus 1 square. So we are going to substitute x equals to, we sub x equals to -1. Okay, we cover, what do we cover? We cover x plus 1 square. Cover means you always cover what you sub. You cover what you sub. And then here, this is x plus 1 square. Okay, so we cover this. So we sub x equals to 1. Okay, and you get your c to be equals to 1 over, this is 1 square, right? So this is also -1 over here. This is -1 minus 1. So it's equals to 1 over -2. Okay, so hence, now if you write out the equation, this x equals to 1 over 4 x plus 1 square plus b x plus 1 x minus 1 plus sorry, negative. So because c is -half, we have -half x minus 1. Okay, then comparing your coefficient, okay, you have quite a lot. Okay, so you compare coefficient, you have 1/4 plus b equals to 1. So you have your b to be equals to 3 over 4. Alright, so I'll leave the working to you. Alright, so this you do some working yourself. Alright, so that means eventually you have your answer. This is x squared minus 1, x plus 1, and in partial fraction this will just give you 1. Remember, this was the quotient just now. Minus 4 over x minus 1 minus 3 over 4 x plus 1 plus 1 over 2 x plus 1 square. Yeah. Okay, so with that, okay, now we are ready to do the expansion part. Now we are ready to do. Just now we were not ready. Now we are ready. Okay, so let's look at how do we do the series expansion based on what we have. Okay, this was the expression expressed in partial fraction. Is there any way that you can write it in a more observable manner? Okay, so we can also write our fx in this manner. Okay, we can also write, since we can actually bring our denominator, so we can write it as 1 over 4 x minus 1 to the power -1 minus 3 over 4 1 plus x to the power -1 plus 1 over 2 1 plus x to the power -2. Okay, this is from the earlier. This is nothing but from here. Okay, then what I'm going to do next is I'm going to try to, because I want a constant to be at the front, I'm going to rewrite. Okay, this is 1 minus 1 over 4 1 minus x to the power -1 minus 3 over 4. Okay, so the rest I'm just rewriting the steps. Okay, so can you see why I put it in this form? Okay, because we are going to do power series. We are going to do power series. Okay, in order to do the approximation. And from this portion, now this is quite this here, you can expand this. You know that this is going to give you like 1/4 from here. This is 1 plus -1 minus x. So this is like 1 plus you know, it's quite a long process. Minus x plus -1 -2 over 2 factorial x square plus -1 -2 -3 over 3 factorial x cubed. Okay, so this is the numerator. Okay, then yeah, so and with that you can also go to look at 3 over 4. So we have 3 over 4. Now you just 1 minus okay, let me just rewrite the quick answer, which is after doing your binomial expansion, this is what you get. How about for the half of 1 plus x squared? So that's going to give you half 1 minus 2x, and then you have -2 -3 over 2 factorial x squared plus -2 negative 3, negative 4, 3 factorial x cubed. Okay, so on and so forth. So at the start you're doing all this working. So I mean, eventually you have to present your answers properly, and simplifying all the coefficient, you would get 1 plus 1 over 4, 1 plus x squared plus x cubed, okay, minus 3 over 4, 1 minus x plus x squared minus x cubed, plus half 1 minus 2x plus 3x squared minus 4x cubed. Okay, and that will approximate to 1 plus x squared minus x cubed. Okay, so this is expansion of your question 3 function. Alright, then the next part is quite interesting. So we need to find the coefficient of x 2005. So we need to find the coefficient of x 2005. So this one, it sounds quite challenging, but actually it's observable. Okay, you can observe, and you just tell me now, if I look at this 1/4, so this is power 1. What's the coefficient of power x power 1? 1. Coefficient x power 2? 1. Coefficient x power 3? 1. So you can see that all the coefficient of x power n, in this case, is just 1. Right? And so from here, you know that the x power 2, you're going to get like a 1/4 here, based on this. Okay, the next one, what do you have? You get negative, positive, negative, positive. So you can see that for all the odd powers, power 1, power 3, power 5, power 7, power 9, power 11, so on and so forth, the coefficient of x 2005, okay, it's going to be, you can see it's negative, right? Because the odd powers is negative. It's going to be negative 1. Okay, so negative 3 over 4, negative 1. You're going to get a plus 3 over 4. How about the last one? So you have half, you have 1, 2, x power 1, 3, x power 2, 4, x power 3. So meaning you have something like n x to the power of like n minus 1. So you're talking about x to the power of 2005. Likely you're going to get, what we get? You get 2006, right? Okay, so over here you have plus half multiplied by 2006. Okay, and this will be your coefficient of your x to the power of 2005. Okay, oh sorry, this should be a, let me see, yeah, okay, one more thing is that you consider there's a negative sign. Okay, so all your odd powers are negative, so it should be a negative, there should be a negative sign. Okay, so this is x to the power of 1, x power 3. So in order for your odd x to the power of 2005, you can observe that here it's actually 2006. And not only that, because the odd power is negative, so over here this should be a negative answer. Okay, and observing from this, okay, simplifying this answer, all you're going to get after that is just negative 1002. Okay, that's all for PQ question 3.